right, now welcome to Crow 777 Radio. This is hour one of episode 650. Jason Lindgren is with me, and we have Luther Peacock joining us for the first time, who we will refer to throughout the episode as just Luke. Welcome, Jason.
And a hot good afternoon.
So what we're going to get in here is what's being called the Divine Emission Theory. We're going to cover all kinds of things from lunar waves to the sun and scalar ideas. We may get into the periodic table, but with that, let's jump in. Welcome, Luke.
Hello. Thank you for having me.
Before we jump in, do you want to lay down anything for people to look at, go to, links, anything?
There is a OSF link to the theory and to the larger theory and the other documents that I've attached to it. So I can give that to you afterwards to put in the notes for the show or whatever.
Okay, and I also understand we're going to have quite a few visuals. Those are going to be linked for members in the comments under the episode when it goes up. But we're going to jump in here talking about scalar wave shells and the living luminaries. And this one's close to my heart. I do not accept that what we call stars are suns, like the thing I film all the time. I don't accept that they're the same thing. And from the sun's point of view, I don't accept that it's a nuclear furnace. And more, I accept wholeheartedly that not only our sun, but what we call stars are conscious or consciousness. So with that, let's jump in, Luke. Scalar wave shells and living luminaries.
Right. So, yeah, I mean, basically everything you laid out, I would agree with. The whole basis of this theory started when I guess made a realization that looking back, I'm like, I feel like all of science should have kind of stopped whenever we figured this out. But it was a little bit after basically relativity was accepted. We got confirmation that light not only transfers momentum, but it also creates pressure. So the question becomes, one, what else? If light is just energy, yes, it's a different form of energy, but if it is energy at its base, does all energy do this? Two, what is it constantly pushing against? What is it constantly giving momentum to? What is happening to that pressure that it's creating? So that led down this whole rabbit hole of creating this theory and unifying basically all the fields of science as of right now. I mean, we have all of classic in here. We have relativity, special, general. We go through particles, go through periodic table, even going to the quantum scale as well. But yeah, it's pretty all-encompassing. The wording is a little bit different than I would say like a standard scientific theory has. And there are documents to specifically outline like exactly what they mean, what's going on, stuff like that. But I've basically completed the visuals for everything, so you can get more than just a verbal explanation. You can get an actual visual idea of what I'm talking about, what's going on, when, where, all of that.
So you mentioned Einstein in there, and just for reference, how do you feel about him? Do you accept what he put forward? Do you feel like it was limiting what he put forward? Or do you have any point of view on that?
I changed my mind about him.
And what was that change?
So originally, I wouldn't say that I had the typical view of him of thinking he just set out to prove the ether wrong. I would say I wouldn't say I was running along that same mindset or that same thinking towards it, but I could see that, and two, I could see just the bigger picture of that. I get why some people don't like him, but after I threw this whole theory together and then started looking back to see what all actually happened, I started looking into Einstein's later years just to find out he realized that he only described geometry. He never gave the idea behind what energy is, where it comes from. He absolutely hated quantum whatsoever. He full out denied it, but he realized that he made a mistake. He tried going back. He even committed, I guess you could say, the scientific taboo of redefining what mass is. And honestly, after finding out that, it kind of made me feel a little bit more justified in the fact of doing that.
So what was the mistake you feel he corrected?
He never actually did it. He never got around to being able to create his unified field theory.
Okay.
sadly he passed away. Looking at his work, I could say that looking at his later work compared to this theory, I could see the direction he was going, and I would say that he was at least heading in the right direction.
And how do you feel about the fifth element idea, where a lot of people try to attribute that he just dismissed it out of hand without experiments? A lot of people claim that the Michelson-Morley stuff was close at hand when all that happened. Do you accept the ether? Do you have any issue as him like dismissing it, as some people claim?
I do not reject it, nor do I accept it. I believe that it was an older field theory that had justification behind it, and instead of like whenever the experiment came out and we found out that it wasn't moving, basically, right?
Well, with the Michelson-Morley, you're talking about the Michelson-Morley
Right.
experiment where they used splitting light to demonstrate that we were stationary.
Correct.
And it seems that Einstein responded at least in that vicinity of time.
Right. And I would say that more than likely, in my opinion, he was a very eager young scientist, and he was, that was kind of like the opposing side. You had two sides. You had the side that was trying to run for relativity, and you had the other side which was trying to run for EM. It was, in my opinion, a pretty big feud that was going on. But the thing is whenever we got the findings of that experiment, the whole encompassing idea of the ether was completely thrown out, instead of saying, all right, well, if all of these attributes match and this experiment says that these ones over here don't match, why did we not just continue modifying it and building off of it?
So I'll lay my cards on the table just to be upfront about it. I think Einstein was hand in glove with the kind of takeover that happened in the early 1900s that affected schooling, science, medicine, everything else. But it's clear he put forward things that were useful. But as far as the ether, what I notice is I think it's an important idea, and mostly because of what you would probably call alchemy or the natural sciences. For a philosophical point of view, the ether is an important idea to me because it was worked into so many systems, some of it philosophically. But it appears to me, and I don't know if you'll agree with this, that the dark matter idea seems to be overriding the ether idea, and that the connotations on dark matter are negative, as you see in like the Marvel movies, where it's a horrible thing that can get in you. How do you feel about those statements, Luke?
I would partially agree. So part of the process of, I went through this whole theory. First, I would say it was my walk with God, basically. So I am religious. When I set out on this, I had my conversation with him, and I said, you know how I think, how I work, how I do. Point me in the right direction, and I will just go, and I will figure it out.
I like it.
Now, even though I did that, I always, at every step, tried to do my best at keeping the religious view out of it for the most part. So I let the science lead me to the religion and symbology instead of the other way around.
Well, wait a minute here. Are we literally saying religion, or are we saying spirituality, or are we saying both? Okay.
Both. Yeah.
For me, there is a massive difference between religion and spirituality.
Yeah, and I'll agree with you. I'll agree with you 100%. One thing I will not do with this theory is I am not going to just label things as coincidences. So if there's something in spirituality that has a very strong connection to this theory, I will not ignore it. I'm not going to ignore it.
Well, for my part, I don't accept coincidences. I think the Hermetic principles, which are logically correct, demonstrate that for something to happen, something else had to happen.
I mean, that's kind of actually in Newton's laws.
Yeah, actually more than one of them. But let's pull back around. We opened up talking about scalar wave shells and the living luminaries. Can we zero in on that for a minute?
Yes. So the whole idea of this theory is that energy emits pressure. It goes through a series of pulses. As these pulses build up, a whole lot of different things happen. Other atoms, other elements, other matter can be created from it. It can create something called a shell, which is basically Schrodinger shells. for example, in his shell, like his whole idea behind the shells, I would say that they are more physical than what was originally thought.
So be more specific about the shells so people comprehend what you're referencing.
So I'm trying to figure out how to word this. In quantum theory, things get a little bit different, right? We're talking about a very small scale. We're talking about, from what they were trying to say, the origin of matter, material, all that. This is before we get to Higgs field. This is before we even get to really virtual particles. This is around the same time that Einstein's doing his thing. So a lot wasn't really known, but he was basically just realizing that there is a kind of a shell pattern to the way matter works, meaning like the harmonics of matter and energy create shells. This would eventually evolve into full quantum theory where we get to virtual particles, we get to quantum foam, we get to probability density clouds, all of that stuff.
What about bigger stuff? Would those shells apply to something like the sun or what we call stars?
In my theory, yes.
Okay.
In quantum, no. They treat it more as a calculation than an actual physical thing. And there is a reason behind that. So, putting it all together, looking back, I realized what went wrong. So, there was a gentleman by the name of James Clerk Maxwell that he is referenced as being the father of electromagnetism. He is the one that gave the paper introducing the relationship between magnets and electricity. In his original paper, there is something called a quarter neon. Now, this word is weird. It's not very heard of. Actually, shortly after, probably around the time of relativity, it was no longer taught in schools, colleges, just full-blown academia. It wasn't taught anymore. And there's a reason for that. It was too complicated at the time.
As theory or as reality? Did the quarter particle exist or is it theoretical?
So he introduced it in 1865, and at the time it was theoretical. He could not actually prove it.
Okay.
So what it is it is imagine a circle, or I guess a sphere, that has three rotational aspects to it. And then there is one basically other aspect, one scalar aspect. This was too complicated at the time, so it got cut. There were three gentlemen, one of them being Oliver Heaviside, which he helped Einstein with relativity, or like Einstein used his work for relativity. Basically, it was too complicated, so they had to cut it up in sections into vector formulations. Einstein, you could actually say that he took basically the skeletal structure of the original equation. Then you have the other side, which is quantum. They took what you could consider either the spiritual or the energetic side of those equations. And then the body, you could say, just stayed in EM, in classical physics. So once you go back and look, you can kind of see. So, for example, Einstein's work has shape, it has geometry, but it has no energy. He could not define what and where energy was. On the other hand, you have quantum that has no structure whatsoever. They say that this structure, such as like virtual particles, it doesn't exist. They just create it in order to mathematically show how mass and matter pops in and out of existence.
So wait a minute, let's define that for a second. So what you're saying is the theoretical particle in this case, I assume we're talking about, is like a make-believe scaffolding that they build up so they can mathematically describe a building that doesn't exist.
Yes, that is what a virtual particle is.
Okay.
And they have diagrams to show exactly how it works, what it looks like, quote unquote, but it's not, the structure is not actually real. It's just a visual to show what's going on with the energy itself, because Einstein had the structure, so they couldn't add a structure. This is the whole reason why, in my opinion, they had to rely on probability. Why, to them, energy, matter, mass, all of that pops in and out of existence. So after I figured out my theory of pressure waves, the particles being the emitters, them having shells, all of that, went back to Maxwell's original work and basically started going in deep. As of right now, I've pretty much been able to either derive everything or match everything to 100% empirical values. Basically, all of physics constants, their laws, Copenhagen interpretations, even going far as redshift, going as far as what they call probability density clouds, but I don't call it that. We'll get into that in a little bit once we get to that part of it, because I'm going to visually show you a step-by-step process of how all of this actually works.
And we're also going to compare, or at least speak about the comparison you made of my solar footage, and that'll relate to your rotation theory. But so in your view, all the quantum stuff you were talking about, is that all theoretical?
For me, it is not theoretical.
For the mainstream, is it theoretical?
I would say halfway. So there is data, right? So like to say, I don't agree when people say that gravity is just a theory, right? Gravity is something that we measure. It has an actual force to it. Now, what causes that is different. But obviously, gravity itself, no matter what you say the cause is a thing that's actually happening, right?
Well, right. I mean, they're putting a label on a thing we can view, but I mean, whether or not you think it rises to a law, it's not actually a law like other laws. If you look up in a search engine right now, this gets danced around because of exactly what you're explaining, because everybody sees the effects. That's not deniable. But I'm just making the point that technically, in a book, it is not a law.
Right. I guess I don't look at it as like, because you know how some physicists, some scientists, all of them, they dance around words. I try to keep it like very clean cut. So like I would say that whatever is causing it is the force. What you are seeing happen to it is the effect, right?
So does this apply within the like minutia that you were just addressing, or if we want to borrow the pun, an apple falling from a tree, that's gravity?
Yes.
The big problem with mainstream is that they don't have a way of uniting gravity with quantum, and that kind of
exactly
it confuses them.
I was just going to ask Jason, how do you feel about the quantum ideas, and also it appears, and Jason's going to be way more up on the science than I am. It appears there's two sets of rules that all of a sudden when things get so small, there's a new set of rules to be followed. Did I get that right?
Well, that's just the problem, right? They can't unite macro scale stuff like with gravity and all that to match up with a lot of the stuff that they say with quantum. Now, what the answer is, I don't really know, but it's probably some sort of multidimensional thing they're overlooking.
Their current understanding is that the macro is governed by space-time, right? Gravity wells, all of that. The micro is governed by electromagnetism. They say that these things are so small that they do not create, like at that scale, magnetism, electricity, all encompassing, is much stronger of a force than gravity can be because of mass.
Right.
Now, my theory, it does in fact link together. It unifies quantum and relativity, or Newton, whichever one you would rather consider, whether locality or talking about much, much larger things.
So if we look at the quantum as it is put forward by people like Maxwell or any of the other people that you've referenced here, is the majority of it theoretical? Is part of it theoretical? Is some of it observable or provable in some way? How would you describe that?
So as of right now, I think it's all the way to copper when we're talking about elements. Quantum can make accurate predictions that we can track to empirical data from spectroscopy.
So using theories, you can get up to the element of copper, and
they can,
and they can say, see, this was correct.
For the most part.
Well, quantum entanglement is the big thing they've proven to keep that theory going, isn't that right?
I would consider quantum entanglement something different. There are some things that I don't necessarily frame differently, but I say it's from a different cause, basically. The whole reason why they could never unify each other between relativity and quantum is because neither one of them ever realized that they were already 1/3 of the actual correct equation. So they were already haunted by each other inside of their equations. This is why we have to have loop calculations with inside of quantum, so that way things don't go to infinity because they don't have a structure.
All right. Well, if this is a good point in the conversation, I'd like to pull this around to a couple things. And I'm actually kind of anxious. You have a reinterpretation of the lunar wave that I'm kind of
Yes.
excited to hear about. Is this a good place to do that?
Yeah, we can do that. We can do that because it'll give a good visual of like everything that I'm talking about, and we can go into like basically subsections as we are going through the visuals.
Okay, perfect. And first of all, I'll just refresh. The lunar wave was a thing I accidentally filmed in 2012. At the time that I did it, I held on to the footage for a year. I was unimpressed with social media. A year later, in the fall of 2013, I posted it to the internet, and a lot of things happened. Let's just say it made a wave. And in that, at the time, I thought it was peculiar to the moon, which it is not. And I thought it was maybe connected to the equinoxes, which I think, well, it may be, but it's not specific to that. And just to finish that thought, I don't remember how it got the name lunar wave or who said it first or any of that. But if I was going to describe it now with everything I've seen and learned, I would probably refer to it as a firmament wave. But getting all that out of the way, just in case people aren't even aware of what the lunar wave is, there's still footage of it in Shoot the Moon. There's 7 lunar waves, 5 that I shot, and the original 2012 wave, which is probably the best I've seen, is also there, so you can see it. So there you go. There's the tee up, Luke.
So I would actually say that it could be both, depending on what is going on in the background. So like,
Okay.
I've looked through a few different videos, and we can go over those as we move through this. But for the first one,
Well, before you start, you are aware that footage has been captured in front of 2 other luminaries, Saturn and Jupiter.
yes, I have
Okay.
looked at those, and as of right now, at least one of them I can say was on the actual object from me like going over the video, looking at it over and over and over again.
Okay, that's interesting.
A couple of the other ones, I would say that matches more towards what you were saying, to where it's a more of a firmament effect.
Well, to be honest with you, that 2012 footage, it really does feel, I've looked at it so many, probably thousands of times, and it really does feel like it's wrapping on the disc we can see. But anyhow, I'm going to shut up. Go ahead.
So, one of the base ideas of this, and it is one of the main first principles, is called emission pressure, right? So, emission pressure, what it does is as it builds up, it releases a pulse. This pulse is sent out as a pressure wave. Now, from the simulation, you can see the 3 original like white pressure waves going out.
Okay, so for the sake of the conversation, be sure you're describing this so it isn't dependent on the visuals, okay?
Right. Currently, there are 3 orange dots on the screen, and each one of them sends out for visual effects, a transparent, like white wave. What you would imagine just as a circular or spherical, just sphere expanding until it interacts with something, basically. Now you can see at this spot right here where they meet, right?
Where you get the Vesica Pisces.
Yes, yes. You can see this extra pressure wave that comes out, right?
Okay.
So this is one of the versions of a rebound wave. This is basically opposite pressure waves interacting with each other. You can view it the same as if you dropped 2 stones in a calm pond, right?
Yep.
Once the ripples meet, if they meet for the most part perfectly, they'll either completely cancel out or they will return, right? They'll go back in their original direction. This is almost a 1-for-1 for what you're seeing go on here. Where these three waves meet, they can either cancel out, just like your standard destructive interference, or they will rebound. And they will also create what you could say constructive interference, but only when they meet asymmetrically. So whenever they meet off angle, right?
So we should describe to people, if you draw two circles and you overlap them slightly, there's that shape called the vesica Pisces. He's doing that with three circles of energy, concentric waves growing.
Correct. You could all day long compare this visual to even as something as simple as just a regular Venn diagram.
Okay, so how does this relate?
So now that is basically the first step, right? So when the three pressure waves meet, they're all meeting at different angles, right? Because this is happening at, I honestly can't even give you a number of how many times this is happening every second in basically everything that you can visually see in general.
Everything vibrates.
Correct. So, I mean, honestly, the amount of these waves going on at one time, there will never be a number for them.
It's infinite.
For the most part, yes.
Yeah.
So when they meet asymmetrically, this must mean, since of course they are pressure waves, that they will create something I call a torsional knot. So because the three of these met at a off angle, you have a kind of turning vortex in the middle of it, but this is a three-dimensional vortex, right? So on camera, you can see, or on screen, you can see three different color lines that are all twirling, for the most part, just into each other at each one has a different direction that it is going.
So it almost looks like a torus, but it's round, and then the center is hollowed out.
Correct.
Like a shell.
Correct. So this exactly right here is what quantum would say is a virtual particle, but this is an actual structure that is going on. This is a real structure. This is not a mathematical demonstration of what's going on with the energy. This is more of a mechanical demonstration of what's actually going on.
Are you using three colors to demonstrate that there were three energy sources that formed it?
It is to simulate three different directions.
So it was the angle at which they came together?
Correct.
Okay.
So you see how all three of them start like going in a different direction?
Yeah,
and not
okay.
not like a reverse turn or anything like that. They're all rotating in the same manner, like clockwise or counterclockwise, but they're going at different angles around that sphere.
As rebounds?
So these are just basically pressure knots. From where the pressure waves hit, it basically creates a vortex.
Okay.
So after that, we get basically, you now have a vortex, right? But it's a three-dimensional one. So when that happens, you obviously have some kind of suction, right? What this does now is this scalar knot will start pulling in available energy that is around it. Once it collects enough energy inside of where you saw that knot, there is now actual energy itself. And once it collects enough of it, it can start emitting basically its own energy, its own pressure waves. So from this one right here, this one's a little bit more visual, and I will explain it as we go through. So this is just currently we're looking at a different type of simulation that I made. It is more three-dimensional, but you can still see the transparent white pressure waves coming in. They meet asymmetrically, which creates the knot, which this is just a different version of visual to describe the knot. The other one is better.
Okay, I got to jump in here. We're going to have a problem if the conversation is referencing images people can't see. So as you describe it, we've got to describe it in a way that doesn't make them think that they should be seeing something they're not.
No, it's so where we were talking about the three pressure waves meeting, where you have just three spheres expanding,
Yep.
and they expand and meet off angle. Inside of that spot where they met at, you're going to have a vortex. That is what I call a scalar knot. You can imagine it just as, basically tying your shoelaces over and over and over and over again, just in a constant motion. You're creating just a spinning knot for the most part. What that does is that creates a suction, right? Because it's just a standard vortex. Once energy, because energy is all around, it's everywhere, all the time. Once that is pulled in enough, you now have what you could consider one of the first particles to exist, right? It's the same thing, basically a tiny condensed sphere of energy inside of that vortex or that knot that we were talking about.
Okay.
Now, this sphere of energy, it's very much compressed. So when you compress energy enough, it basically pulses. It's almost similar to, for the most part, a combustion engine, or like a compression engine for a diesel. You are compressing that energy so much that it now, I'm not going to say ignites, but it is a similar fashion to igniting, to where the whole thing just expands. So now this compressed energy has expanded out. That expansion that it created is literally the same thing that you saw in the very first visual. It is the three pressure waves that met. So these three pressure waves that we saw in the beginning, or that we described in the beginning, of the translucent white spheres meeting off angle in the middle, those three were created by this. So as that compressed energy expands, it sends out a pressure wave. Now, as it keeps pulsing out that pressure wave, you have a collection of energy. So imagine you just have energy compressing and expanding over basically a lot of times per second in the same area. This creates a more dense field of energy, right? And you're still collecting more energy because of that knot that is in the middle. So it just continues to build and build and build over time, to where you start getting the very smallest particles that we currently understand in science. We don't have to get fully in depth of all the different particles and all that, but this is the engine that is created and collects energy to become the first particles.
So how do you draw the line to the lunar wave from what you've just described?
Because the way that those pressure waves start interacting with multiple pressure waves, and then also interact with already established structures, right? And in this theory, the micro works the exact same way as the macro does. So where you saw those pressure waves coming in at, and you saw how they overlapped, like the Vesca Pisces, right?
Yep.
It's the same thing.
So in the lunar wave footage, for those who haven't seen it, it's two waves. And what I consider to be a lunar wave, or very similar to each other, so they can probably be described with the same moniker, they're in pairs. Why is it in pairs, Luke?
It would have to deal with the setup. I mean, if it has, so in this visual that we're now seeing, we have another pressure wave, but it's just one in the center, right? So just a transparent, expanding sphere. Now, next to it, there is basically it just looks like a see-through crystal sphere, however, a little bit translucent, but it itself is not emitting. We're just showing an example of how pressure waves travel across surfaces. So do you see the wave that's going across here? You can see as the pressure wave hits the structural sphere, a purple ring develops and it rides around the surface of the sphere.
Right. So in thinking of it this way, we're looking at the lunar wave. We see two waves. Each one would be its own pressure wave.
Correct.
And so then we've got to ask the question, where'd the wave come from? And I'm guessing you're probably going to say the sun because it had to come from some kind of energy, right?
Absolutely. So as of right now, in our immediate vicinity, no matter what distance you want to say, the strongest and most prevalent emission source is the sun. So the sun is constantly sending out these pressure waves that you are currently seeing. Basically, imagine the sun pulses and sends out a spherical pressure wave. This interacts with everything and it creates a pressure gradient throughout everywhere that it travels on a constant basis. So, as this ring goes around the sphere and travels across the surface, there is already going to be another one moving and establishing because it is constantly pulsing and sending out pressure waves. It's almost exactly the same way as you see waves just coming in on the beach and interacting with each other. Just a constant source of wave after wave and interacting with each other. And you can get, sets of waves like on the beach. They can come in sets of twos, they can come in sets of threes. It depends on what the pulse rate is of the source that emitted that pressure wave.
So by that theory, all the lunar waves we've seen, there are 5 in Shoot the Moon that I shot. There are a couple from Randy in Houston. Of course, we've seen others. We've even seen ones where people started filming and they didn't quite get the first one all the way, but the second one, that would imply that the pulsing from the sun is creating pairs.
Yes. And also, as this purple ring travels across the surface, if it has, for say, excess energy, right? So the moon itself is absorbing this energy as it travels across the surface. As it continues going, if it has enough energy, once it gets to the other side and basically compresses back down to like a very small ring or a even like something that would look similar to a particle just based off of this size, it will now rebound and send that wave back. And as two waves come in from different sides, obviously one is going to be weaker that has already traveled across the entire surface. As it interacts with the other one, it'll start going in diagonal directions. It can overlap. One can be destructive towards the other. One can be compounding the other or constructive to the other.
So I guess I would suggest this, using the theory you just described as a basis. And since we have a decent number of probably authentic lunar wave captures to include across Jupiter and Saturn, one of them twice, I don't know which one, probably Jupiter, that would mean what I was going to say is we have shown them in every angle you can imagine. In other words, the first one was from the bottom up from my point of view. Other ones were coming down from my point of view. Other ones were at a diagonal. That would have to be related to the position of the sun with regard to the position of the moon. So what I'm saying is, with all these lunar waves and the dates they were shot, you could start to figure out if that's correct by where the sun is, couldn't you?
Yes, but here we get to the next issue.
Okay.
Because the moon itself is going to be another emission source.
Do you accept that the moon is dirt and rock?
No.
Okay. I think plasma is probably the closest. I call it a luminary right now, but anyhow, go ahead.
So the moon, as far as visual, is actually, in my opinion, dependent on the sun, but it is not from direct sunlight.
I agree with you.
So it seems like the composition of the moon, it is more of a absorbing source than it is a emitting source, even though it emits in general.
Almost like the philosophical idea of gender, male and female, positive and negative. Sun and moon, I mean.
Right. So I would say that the moon isn't all the way to the other side of the sun, though. I would say it's kind of like halfway, because once enough pressure builds up and it really starts emitting its own pressure waves, you'll get some very interesting events. All of them actually completely track with the solar and lunar cycles. For example, currently the moon is typically always white, right? Well, for the most part, it's got a very high albedo effect to it, right?
Oh, okay. I see what you're saying. Yes, it's very bright.
Right. But you'll notice as it goes towards the horizon and basically becomes a moon set, right? So you have moon rise and moon set, the same as the sun.
Yep.
The issue is that there is absolutely no reason under the standard model that if the moon is nothing but reflected sunlight, there's no reason why it should not redshift the same way that the sunset does.
Well, I got to point something out here. Anyone can pick up a ball, go into a room that's dark, put a flashlight on it, and you will see how reflection off a sphere happens. It comes to a point on the face. This is not what we see in the moon.
Oh, absolutely. Yes, you are correct.
I get what you're saying. I know you're making the point about the redshift. I'm just pointing out that a common sense approach proves that what you're putting forward is reasonable, because the description we've been given is patently false and it doesn't take a lot to demonstrate.
correct. So one of the reasons I took another approach to it and talking about things that do not match the standard model. One like that's been talked about for I don't even know how long. We're talking about centuries, millennia, talking about that, which it fully 100% stands, but it's almost to the point to where like they just don't address it anymore. You know what I mean?
Right. Yeah, sure.
So I'm meeting them on a physics level and bringing the issue.
With their tools, you're talking about redshift. And so you're pointing out that if your redshift idea here can be applied to all these things, why not here?
Exactly.
So that's a proof of its own using their toolbox.
Right. So one of the interesting things is that, of course, we notice that the moon does not redshift. This is actually because the moon's opacity and how much is visible is solely dependent on how much pressure it is receiving from the sun, because it takes this pressure and basically absorbs it to eventually become its own emitting source, right? But it works off of a cycle. So as energy builds up, it becomes more visible. And for the most part, it does not actually emit the lower part of the spectrum more towards the red side. That is why it does not redshift on the horizon, because it does not have any red light to begin with that it's showing. It's not a reflection of light, and it's basically holding on to that red light until the point that it gets overwhelmed. And then you have situations of blood moons, of harvest moons, all of these celestial events that they completely line up with how much energy it is storing over this time frame.
So, but wait a minute. You said two things there. You said it doesn't emit the red because it's reflecting from the other end
Until it builds up.
So if you look at the visual spectrum, you'll see what we see with our eyes is just a little narrow sliver. It's 0.003 of the entire electromagnetic spectrum that's visual to us in colors. So on the side that red is, if you go further, it's infrared. On the other side, where blue and purple are, it's ultraviolet. So are you saying that it's emitting from the ultraviolet side, or what exactly are you saying?
So the sun puts out almost all of the spectrum.
Right.
The moon will basically take that frequency, that energy, and it'll bounce back or emit the rest of the energy, but it will actually hold on to the red spectrum until it builds up enough to basically turn into a full blood moon.
Oh, so, okay.
That's whenever we get like the full red color coming out of it, because it holds on to that part of the spectrum.
So this is an interesting topic. because of the media's insistence on saying ridiculous things like calling it a blood moon and other things, which back in the day, just to be clear, was a name for the moon, not because of its color, but because winter was coming and people were going to have to hunt. That's one of the reasons they claimed that was actually called a blood moon in certain cultures. But I filmed the moon for 5 years straight. And there's a couple things I wanted to ask you. One of the things I wanted to ask you is I once shot for over a year, actually a year and a half, trying to catch another lunar wave and couldn't. But to get back to my point, what's in the atmosphere has a lot to do with the color of the moon, but sometimes it doesn't feel like that's true all the time, which is why what you're putting forward is interesting, because you're saying at some point the buildup of the infrared side of the spectrum is actually changing the color of what we perceive.
Correct.
Which is an interesting idea. But to pull it back around, if the sun is providing the waves that are the cause of the lunar waves, do you have any idea why we can go so long and not see them?
Yes, it has to do with one of the other first principle variables that I have, which is called coherence.
Okay.
So currently, as of right now, quantum has a variable called decoherence. And I have that as well. And we both actually agree on what it represents. So in this theory, in divine emission theory, there is a factor called coherence. What it represents, it is a 0 to 1 scaling factor on how structured this object is. It can be a local factor or it can be a bulk factor, which we can get into if we get into the periodic table. But basically, it's like when multiple elements build up into cells, into actual structures, into living organisms, all of that stuff. That's all bulk stuff. But as far as local, so it goes from 0 to 1 and it represents how structured this object is, how much does it retain its memory, because memory is actually a scientific like thing that we hold. Like science holds that energy has memory all day long. They admit it. They don't talk about it a lot, but they completely admit it. So that is part of what coherence is. It is also a factor of if it is altered in some kind of way, how well does it hold on to that structure and memory? So when we enter a rate of drop in coherence, this is what is called as decoherence. Basically, it is slowly losing its structure. It is slowly losing its memory. It is slowly losing its entire form. And it's basically starting to expand, right? Because it is no longer being contracted anymore. It is losing its actual structure. This is where wave particle duality comes in. Because if you take a point particle and you expand it, what does it start looking like? A wave. This is why in the double slit experiments, they got the interpretations that they did, to where if a particle is left to, if light is shot through vacuum slits and then you basically have a target on the other side, it will decohere and the energy will expand.
Doesn't observation play a role in what you're describing? The fact that it's being observed or it's not?
Yes, and that actually has to do with the coherence of what is going on around it. So if you have something in isolation, it is obviously going to expand. It's almost like a vacuum type effect, but that's not actually what's going on. Instead of it being sucked apart, it's losing its internal structure to where it can no longer contain itself and it expands.
So what you've described as coherence or decoherence, how does that relate to not being able to catch a lunar wave for like a year and a half? And I was going almost every night and I was putting in the hours.
Because coherence it varies a lot, and the entire electromagnetic spectrum depends on coherence. And also, coherence has another part of it, which is opacity. So you basically have to have a good situation going on to actually visibly see what is going on, because for the most part, it's a translucent effect unless you're looking at something being affected by it.
Right. I don't think you could have even seen the 2012 lunar wave with your naked eye. I really don't. But we're getting close to the top of the hour. Jason, do you want to get anything in here? And by the way, Luke, I wanted to mention, if this theory, as it might relate to lunar waves, vis-a-vis the sun, wouldn't it follow that when the sun is more active, there would be more lunar waves?
Yes, absolutely.
And wouldn't it have to do with the positions of the objects in space?
Yes, it is not as reliant as what the standard model currently has. So it's not as much of a visual lineup, but more of a just geometric lineup.
Well, I can make two suggestions off the bat. Most lunar waves that are around have dates with them, and you can relate that to how active the sun was. But more importantly, I think, is what angle it was viewed from and what was the position of the sun. Now, this gets tricky because I am a firm believer that a big part of when the moon, like the moon, people don't realize it. We see the same face with very little change.
Yes, it's tidally locked.
Right. It tips a little bit forward. It's called libration. You can look it up. Tips a little forward, tips a little back, which gives us a few more percent of the face we can see at a given time. But if you watch the moon and pay attention, if it was a pizza and there was a pepperoni at 12 o'clock, as the night goes on, that pepperoni will appear to go down to the 3 position, then down to the 6 position. I think that whole thing is perspective.
Yes.
That the moon is moving away from us. It has nothing to do with the moon rotating. And that's my point of view. But there are people who spent a lot of time on the moon who did demonstrations to try to back this. But we're like jamming up on the top of the hour. Jason, do you want to get anything else in here?
Nope. Let's move on to hour 2.
Okay. We're going to have to take a short break, Luke. Was there a thought you wanted to complete? Go ahead.
Yes, there is one thing. So in Maxwell's original work, he discovered something that was actually very interesting about the quaternionic structure. So if you want to visually imagine in the simplest form what is going on with the 3 rotations, right? Imagine a gyroscope to where each one of them represents a different rotation. He also specifically outlined that all of these, whether we are talking about micro or macro, are going to experience the standard, completely understood precession that gyroscopes naturally have.
Okay, we're going to put a cut point right there. You okay with that?
Yeah, you're good.
Okay, go ahead and tell folks where they can find you or your work if you wish to do so.
So if you want to email me, you can email me at all capital DET and then all lowercase theory at proton.me. I know it says theory twice because theory is obviously in the name, and I apologize. That may be the best place to reach me at currently. I think we are going to give the link for the actual theory and all that stuff, so we don't have to go into that because that's a whole HTTP link and all that stuff.
Okay. Well, that brings us to the top of hour 1 of episode 650 with Jason Lindgren and Luther Peacock, who we are calling Luke. We're going to take a short break and we're going to come back for hour 2. There's so much more that we're going to get into. Thank you for hour 1, Luke. So fascinating. I put together a thought experiment for myself years ago because I was getting frustrated with how many theories never become anything more. So I'm going to say this thing, think about it while we're on break, and I'm going to ask you to respond to it when we come back. I invented a thing for myself called Crow's Law of Theories. It is not a law. It is a personal thing that I created to help me think about things. And it goes like this. Any theory that remains unproven for years is a speculation of diminishing value and will therefore tend to be applied as propaganda in support of scientism the longer it exists. With that, the first hour is free to everybody at crow777radio.com. Members know to log in for the full episode. Members get access to all the forums and comments sections, and they can create top-level ideas to talk about. They also get access to the film called Shoot the Moon that has 10 awards in the world, last 2 coming from India. And that covers all my older telescope work, which we have referenced a lot here. A lot of it is about the moon. It also contains the discovery of the so-called second sun. Also on the website is exclusive access to my solar work. I no longer post that on social media for censorship and control of any kind. And lastly, there are stills that people requested that are also available on the website. We're going to take a short break. We're going to come right back for hour 2, and there's a lot more we're going to get into. With that, I'd like to wish you all a happy, healthy, and higher-minded new era. There it is, man. Cheers.
Belief is the enemy of knowing.